Nice. That's what you call carbon tracking. 1966 RCA color remote set part 2. If you didn't catch part 1, go check it out. I'll try and remember to leave a link in the description. I have the SAMs here for the set we're working on, also the 15, the CTC16, because I talked about in the first video that the flyback is missing out of this set, and I want to try and put the CTC15 flyback in this set because it has a solid state stick rectifier where this uses a tube, and when the flyback was removed they just cut all the wires off. Anyway, this set is a resurrection, which means we're not restoring it, we're just trying to bring it back to life. This is part 2, and we're going to attack the chassis a little bit. Now this chassis, this whole TV was a big rat's nest. So the first thing I want to do is we'll go after it in sections, and we'll start with the horizontal oscillator high voltage, which is basically the bottom part of the schematic. And so 6FQ7 dual triode oscillator AFC, the horizontal output tube, and then the high voltage rectifier and the damper. We're going to start with trying to make sure the oscillator is running. Now the oscillator tube goes in right here, and as you can see we got some cleaning to do and also some soldering to do. So we'll start with that, and then we'll bring the chassis up on a variac and watch our voltages without any of the tubes. The only tube we're going to start with is that one. Then from that one we'll move on to including that one, and then if we can get a nice drive waveform like that on the control grid of the horizontal output, then we can move on to the flyback and the damper and the regulator and all that other stuff. So first thing we want to do is try and get the horizontal oscillator to run. I would rather not pressure wash this if I can avoid it.
With a mask serving you.
Trying to
tell you how deadly those masks are. Breathing in your carbon dioxide and all the filth. And you got these people, servers in restaurants, wearing them over and over again.
So that thing that's the solders are broken is what supplies the power to the plate of the horizontal oscillator, and you can see there that looks like it's broken for a long time. This one right here, there's a lot of stuff broken. I was looking, there's a wire cut off here. This is broken. I think when he removed the flyback he literally just ripped it out. Just brute force style, rip it out, throw the chassis away. So this is going to take some time to figure this out. Let's see if we could get this oscillator to run. I cleaned and checked the horizontal hold control pot. Now I got this soldered back in. I checked all the solder joints. It all looks good. Now I just need to find the 6FQ7. Now I'm cleaning the wonderful rat infused tube socket. Wow, the contact cleaner activated the scent of the rat glaze. It's awesome. I'm going to power this up with a variac, and I'm going to watch for DC volts at this junction, this is the resistor VDR combo we soldered, because that is the plate of this, and we'll keep an eye and see what the DC voltage does here. I don't know if this is turned on or off. This motor thing, it has a totally different feel to it. But here we go. Okay, I'm at 60 volts on the variac. I should have something here. Ugh. Yeah, absolutely nothing, and that's not right. So we got to get underneath here and see what's going on. Right off the back of the power plug we have nothing, 0 AC volts. Is it seriously just the rat glaze is so thick on here it's not conducting? And the rivets broke off of this, they're all corroded away. Clean those up. Let's see if that improves it at all. 48 volts, there we go. I can't believe I've never seen where it wouldn't make contact because of rat glaze and corrosion. While I'm down here, I'm checking the circuit breaker because these are a high failure rate. If I push it in, it goes up to, geez, 100 volts. So it's conducting, it's working. Okay, that's good. I'm back on DC. I'm back on my B plus supply that goes through the VDR and the resistor to the plate, and I have 165 volts at that point. Let me go up on the variac a little bit. Okay, there we go. Now if we get on the other side of the VDR, which is here, VDR is a lot like a Zener diode. It won't start conducting until you hit a certain threshold, and I haven't hit that threshold yet. 90 volts on the variac. And I'm watching this here. When I start to get up to around 120 volts, I'm at 2 amps. That seems kind of high. Well, it's dropping down, so it might be capacitors reforming. Yes, it is definitely dropping down. So let me back off on this and leave it at 60 volts for a while. Yeah, I'm very slowly working my way up here. The current keeps dropping as the electrolytics reform. I wouldn't care about reforming electrolytics other than I don't want to change them because this thing's going in the trash when it's resurrected. You know, it's cheaper and easier just to replace them and try and reform them. Now what I'm waiting for is this thing to, I should see some light from this. I'm not getting anything. Okay, now I'm starting to get some light from it. I'm up around 110 volts and I'm feeling it getting hot. Looking at pin 2 here, and this waveform is not going to look right without this tube in it. In order to get something that looks like this, the tube has to be in. And we really can't run it with the tube in without all the flyback. What we should be getting the oscillator should be running, and I'm clipped on there and it's not. It's flatlining. So I believe this circuit should run freestanding on its own, and it's not. You know, rats will eat this stuff up and just ruin it. We're going to ohm this out. So pin 8 to ground should measure about 49 ohms. So 1, 2, 3, 4, 5, 6, 7, 8. And it's open. One, 2, 3, 4, 5, 6, or 9, 8. It's open. Shit. This is gonna be one hell of a resurrection. So that is open. See if I could let's see if I could check the other one. All I need to do is see if there's voltage on, well, not really. I was going to say all I need to do is see if there's voltage on the plate, but, well, I could. That might give me an idea. So there should be voltage on pin 6. So I guess I could check this one, at least half of this double winding, seeing if there's voltage on pin 6 of the tube. See, 9, 8, 7, 6. 366 volts. That's with about 100 volts on the variac and no load. So I'll take that. So this coil here is open. You might be wondering, why did I jump right onto this when the oscillator wasn't running versus any of the resistors or capacitors? Well, the reason why I suspected this is just the rat damage. I'm just looking at the big picture, and you know, it just looks damaged. So let me see if I can. It is indeed open. I believe it's this top coil. Let me see if I can find where it's broken. So I soldered onto that wire there and still don't have any continuity. So I'm looking, what are these stab marks in this thing? Are these bite marks? What are these holes? Let me unwrap this. Wow, look at this. What the hell happened to this coil? You know, I reserve the right to pull the plug on this resurrection at any point. This thing is in really bad shape. Wow. Here's a stripped out CTC16 chassis, and according to the SAMs, this coil is the same. It's the same part number, even though it looks totally different. Not totally different, it's just different tape. So let me get this off of there. You can see this doesn't have the VDR. Someone replaced the phase detector on this. Uses a different vertical output. All the resistances check out on this one. Of course, it doesn't have holes chewed in it. I believe the oscillator is running now. Well, it's doing something here. It's not real stable. There we go. 45 volts. That's AC on the control grid of the output tube. Actually, our signal here looks fairly nice. It's up a little bit high. I could turn the horizontal hold. Let me see, bring it down. It should be about 15.5 hertz, 15.5 kilohertz. Okay. And our signal looks okay here. I know it's hard to see. I'm going to pop a horizontal output tube in. I have some used ones here because you don't want to run a horizontal output tube without the plate cap disconnected for very long because it'll cremate the screen resistor. So this one tested basically 40 out of 80, so this one's junk. So what we'll do is we'll pop that in. And let me bump our voltage up to 1, a little bit higher, like about right there. And is it getting hot? There we go, now it's starting to glow. So let's see, because the tube will affect, and you can see how it's, the frequency's kind of moving around because there's no phase lock or any of that. Let me try wiggling this tube around. See how crusty the socket is. It's a little crusty, but not too bad. Okay, I'm going to let this warm up for a few minutes. Okay, so I'm fairly happy with this. The peak to peak looks right, 173 volts. The waveform looks right. This is the most important, well, not the most important, but this is the key foundation to a working high voltage horizontal circuit. This right here, having this oscillator running at the right frequency with the right waveform. So our peak to peak is 179. They say the peak to peak here is 190, but that's with the whole thing working and the feedback and all of that. And our voltage is negative 50. Watch what happens if I yank this tube out. So I'm saying you have to have this tube in there for the voltages, because this tube kind of acts as a rectifier, as a diode to that screen voltage. Not screen, control grid. The pin 2. So yeah, if this is not in here, and you don't have to have the plate cap on, and it doesn't have to be a good tube. Like I said, you don't want a good tube. You want a sacrificial tube when you're doing this kind of work. But yeah, negative 50, that's about what it should be. That tells you your oscillator's running. Like if I pull this out, now the tube will start to go into self-destruct mode, the horizontal oscillator. So we don't want to do that for very long. And one other thing, checking pin 1 right now, which is basically B plus coming through this 13K and this 47. It should be 135 volts. See how it's 78? That's because we don't have the plate cap connected. So without the flyback plate cap connected, you're pulling all the current up through these two resistors. And if I put a good tube in there, they would start to smoke. See, if I pull this out, goes right up to 412 volts. So that's what happens if the tube is not getting its power through here, it's trying to pull it through those resistors. That's a simplified way of explaining it. A few corrections. This chassis that I'm pulling parts off of, I pulled the horizontal coil off of, is a CTC12. It's not a CTC15. It's a CTC12A. A lot of these, I sat down and did some research, and a lot of these coils and components are the same part number all the way from CTC12 up to like CTC35. or really into the, till they went to solid state. For instance, they were using the same coil, and I was looking through my stash, and I actually have a new old stock one here, 112866. So here's a new old stock. Look at that, all nicely coated in wax. No teeth marks. Look at that, beautiful new old stock RCA horizontal coil from the 60s and 70s, horizontal frequency. The other parts we're going to need are the peaking coils, and these are 620 microhenry peaking coils, and they're peaking coils. You can't go on DigiKey and buy a 620 microhenry RF choke. They have to be peaking coils. I've tried buying the modern ones and substituting them, and you get a soft blurry picture. So when it says peaking coil, you gotta buy a peaking coil. The 3.58 megahertz color oscillator coil is good on this one, and as well as some of these other ones we might need, but this is a CTC12. The next thing I need to do is find a way to mount this chassis on the back, and usually these two tabs mount on two screws here, because I'm going to keep flexing this thing when I tip it over, and these wires are going to start failing. So let me figure that out. This is the electric motor that turns the volume control. And look at this. The Lionel Corporation. So is that the same as like Lionel Trains? Is that who they contracted to build this? Let me just take a minute to kind of talk and go over some of this stuff, how this works. So this is the horizontal oscillator. This drives into the horizontal output. We have the damper here. Those two basically run the flyback. Back here is our high voltage regulator shunt tube. This is the vertical deflection, the vertical multi-vibrator tube right here. This board is basically our video and chroma board, with exception of a few things, like this is the horizontal efficiency coil. This is what you adjust to minimize the cathode current on the tube. But the primary job of this is to decode the color information and turn it from a signal coming through the IF, through the tuner and IF, into color information that's fed into the CRT that gives us a color picture. This tube right here is the video. So we can pretty much run without a black and white, without this tube, with this tube and all of these missing, we'll get a black and white image. This back here is the IF. It comes in from the tuner into here and is amplified. This board right here, besides having the power supply diodes on it, the low voltage rectification from the transformer, and the degaussing thermistor and VDR, this is our sound demodulation, and that's our audio amp, audio output tube. This right here is sync. This decodes our sync. So this feeds into the sync signal, basically into this tube and this tube. So the sync comes off of here, into here, decoded. The sync, the video also comes from here into here, and then into the CRT for a black and white picture, and it comes from here into here for audio, from here into here for color demodulation. This is going to be the hard board to fix right here. We have broken peaking coils, missing oscillator coil. One of the wires on this thing is broken off and just hanging there. Broken off capacitors, other coils that are loose. Probably corroded and broken. I mean, this is going to be We'll be able to get a black and white image probably pretty easy so long as the front end works. But the rest of this is going to be challenging. There was a lot of interest in this remote chassis, take it out and ship it to me kind of thing. This thing is in really bad shape. I think you could probably find a better example of a CTC16 remote upgrade. I mean, this, who knows if these motors work. These are germanium transistors and these old black capacitors that fail, and germanium transistors don't do well in general, and they really don't do well in this environment with this rat piss and super humid and rusty. And so anyway, I got this mounted on here because I'm going to keep flipping this over, and the rats have also eaten the wires here. Here. Are you sick of listening to me talk yet? I know it pisses some people off. Maybe I should just keep going for a while. I'm sure this really looks intimidating, but it's actually not. It's just a bunch of circuits in a path, and the signal flows the path, and it's really kind of that simple. So all we have to do are work on stages, one stage at a time. And yeah, this is going to be a long video, but yesterday, or so far, we've verified the transformer and filters and low voltage rectification work, because we got the horizontal oscillator running and we got a signal to this tube. Now the next step is we get a flyback in this and we try and get high voltage. So it's just one step at a time. And then from there, what we'll do is we'll try and get the vertical working. That'll verify, did the vertical output transformer get chewed up? Are there open windings in it? Because it looks pretty bad, actually. This is another sort of unobtainable part right here. Vertical output transformer. And the thing is, we need the high voltage to get the vertical working, because it uses the boosted 1200 volt source from the flyback to run the yeah, I could get this hand thing going. I could maybe cut me a hip hop record here. What do you think? Get a little BLM action going. Actually, maybe it's more like that. What do you think? Anyway, where was I? Oh, we need the horizontal high voltage working to get the vertical multi-vibrator working to see if we can, to see if we got vertical. Okay, let's do a little testing here. This is pretty much a new old stock CTC16 flyback, and if you hook this thing up to pin 1 and 2, you can drive the flyback. This is really made for solid state, but there's what we got right there. I don't know if that's visible. And then what I'm going to do is I'm going to take this just from any pin and short it to the plate, and you can actually draw a short off of there, but you see it says AC short now, and this will spark. So 10 milliamps, 64% efficiency. This is the flyback that was out of this set that was bad, and he recovered it with silicone. Let's try this one next. A little bit different on this one. 7 or 8 milliamps, and when I spark it here, it goes up to AC short. Yeah, this one's a little different. 33 milliamps. And yeah, I can draw a good arc off of this one if I... And same thing, it goes up to AC short. So I might be hooking these up to different pins on this one and this one. I need to get the schematic and do some research, because if we're going to install this one, then this is out of 15, and I have a bunch of these. So it'd be better to for me to use one of these. And okay, this is about as sloppy and dangerous as it gets. This is our CTC16 series Flyback, which these are fairly common because there was tons and tons of clone chassis CTC15 in our CTC16 chassis. And it's kind of hard for me to explain all the little modifications. I don't even know if it's going to work. But basically, on the 15, most of the focus and high voltage components are mounted on this board. So you have to adapt this to the 16, which most of them are underneath. So this right here, number 5, these numbers that I wrote on here represent the numbers, the pins that match on the numbers that would be on the 16 Flyback. So if we were looking at a 16 Flyback, so it matches, these numbers match it to this chassis. So basically 1 is the bottom of the Flyback stack, then 2, 3 and 4 are where your centering pot hook up. 5 is the plate of. On the 15 Flyback, the damper hooks to a separate pin, which I got D3. On the 16 Flyback, it would hook to 3. But we're going to try it hooked to where they want it hooked on the 15. We've completely eliminated the focus rectifier tube that the 16 uses. Are using the focus selenium solid state rectifier stick that the 15 uses. And this is coming off the focus rectifier over connected to the lead that was connected there. He had already cut that off, or else I would have just left it connected. But like I said, this is not something you want to do unless you're on a suicide mission big time. I got this grounded right here. I drilled a hole in here and grounded, kind of mounted the Flyback, because right here is where the bottom coil, the phase detector coil that's on the bottom of the core, that coil down there, and I have that connected right here where it would have been on the 16. So it's hard to explain it all. You kind of just have to look at both schematics and figure it out. I don't know if it's going to work. We're going to try it. We'll bring it up on a variac. If it works, we should get a nice fat spark off of this jumping from here to the can. Also, when he ripped the Flyback out, he broke one of the wires off the focus coil. I fixed that. We have to hook the yoke up. This circuit will not produce high voltage unless everything's in the circuit. It's a tuned circuit. So for high voltage to work on pretty much any set, the yoke has to be in place and hooked up. The focus coil has to be in place and hooked up and working right. I hope this is not open. So far on this set, the coils have all been bad, either broken or chewed up. Looks like we got, I don't know, it's fluctuating, 3 or 4 ohms here. I don't know, 1.6 ohms. Make up your mind, but at least it's not open. You can see here where I had to fix the focus coil. I'm going to measure as we fire this up. See this diode right here? That's the boost rectifier. So I'm going to measure, the boost rectifier goes to that 0022 filter right there, and then to that 100K, and on the side of the 100K that I have the clip on, there's supposed to be 975 volts. I'm going to watch that as I bring it up. Alright, I'm about 70 volts here. Gives me about 235 on the boost. The damper is in. All we need for this circuit to really work is the horizontal output. Keep that in mind, that that's weak. The horizontal oscillator and the damper. All this circuit takes is 3 tubes. And the yoke has to be hooked up, and assuming that this flyback is going to work in here. So here we go. At 110 volts now. That gives us 350 on the boost. This horizontal output tube might not be good enough to do this. I might have to get a good one, or a better one. Okay, I'm going to come up a little more on the Variac. Okay, I'm at 120 on the Variac now. Nothing so far. Okay, now when I connect the high voltage cap here, my voltage is dropping, which is not a good sign. It's 400 with it disconnected. With it connected, it's 369. So that's not a good look. Okay, measuring our control grid. Make sure the oscillator is still running. It's negative 47. That looks good. Measuring our cap here. Plate cap for the horizontal output with it disconnected, we have 388. Measuring the plate cap with the damper removed, we got 41 volts. I guess that's acceptable. Okay, let's watch our cathode current on the horizontal output. These should run about 200 milliamps, or I think about where I marked it right there. Of course, if something's not working right, it will exceed that. Which it looks like it's going to do. So if we pull this off, it goes down to 30 milliamps, which is what it's pulling through the screen resistor. So something did not work out right. I guess it does no likey this flyback. Hear that? Maybe this damper is bad? Okay, I changed the damper. And the cathode current came down, and look at our boost voltage. And I hear sizzling. .600 volts. Ooh, I smell it too. That thing's gonna getting ready to pop off an arc. And there we are, right up on our brown line. Ooh, the camera went clinky dinkler over that. I hear it screaming too. Let's try a different. My B plus is right on 120. This is pretty intimidating. Okay, since this is a different flyback, I'm going to try and adjust the efficiency coil just temporarily. if I can bring it down to a null here. You can hear going down the high voltage. Going down, the current goes up, the high voltage goes down. Going up, the high voltage goes up as well as the B boost. So about right there. Going up on the variac a little. Still only got 670 on the I might try a different horizontal output tube. That thing's cranking, man. Watch when that does that. Watch the cathode current. Wow. So this damper is shorted, which would probably make sense if the flyback burned up in this set previous, and this was in fact the damper out of the set. It would kill the damper. So you see what a bad damper will do there. Okay, this is with a stronger horizontal output tube. This one was a 40 out of 80. This one is a 60 out of 80. Doesn't look like it's doing anything actually. Make sure I got the filament going. There we go. I'm right at about 118 volts right now on the B plus on the line supply. Watch as it, can you see both of those? As the cathode current comes up, the boosted voltage comes up. 470. Again, this is a slightly weak horizontal output tube. I'm not putting my prime material in this set. 500 on the boost. Let me turn this up a little bit. This up to 120, put the heat to this thing. Geez, this one seems like it's in worse shape than this one. Go again with the tube tester and its BS results. 630 on the boost, 180 on the cathode current. Here it comes. Like to see our boost a little bit higher. 660 on the boost. I think we're supposed to be at 975. Hear that thing. There's no X radiation right now because I don't have the rectifier tube in. Once I put the rectifier tube in, and the shunt tube, that's when we get the X-rays. This is just corona and ozone to the max. Please watch this if I turn the horizontal hold control. Okay, this is not good. Doing that for a second's okay, but on tube equipment, doing it for a second's okay, but not just doing it. It'll destroy something. This is interesting. Watch if I disconnect the yoke. The cathode current drops and the airplane takes over. If I disconnect the yoke, the cathode current drops and the B boost goes up to 930. I hope there's not a problem in this yoke or some other tuning issue with this flyback. All this stuff has to work together, and it might not be. Alright, I'm going to try it with the rectifier tube. Wait, here we go. Next step after this is to put it back in and see if the oh yeah. Oh yeah. I don't think we need to do that for very long. Next step is to put it back in. I don't even think we need to connect the shunt tube. We'll just run it on the variac. All this tube does here that connects to this wire is regulates the high voltage, but we can run it low on the variac and just get it in there good enough to see if the vertical oscillator is running, and then we can start to repopulate the tubes and hook all this stuff back up and hope it works. Replace these broken coils. I got the high voltage hooked up, I got the CRT hooked up, I got the vertical oscillator tube in there, I put the video output tube in. I believe you have to have that to get light on the CRT. None of the other tubes, just horizontal oscillator damper, horizontal output, vertical output, high voltage rectifier, and video, and I got everything hooked up. You have to have the convergence hooked up or else you don't get good vertical deflection. I just want to see if the vertical deflection works. Maybe we can get some light on the screen. I don't think we need these hooked up. All we need is the cathode pulled low, and we need the screens high to get light or a raster. And a raster, I mean no video, just blank light. So here we go. Let's see what happens here. We'll come down. I have to be careful because this white Teflon wire here is a live, it's basically CRT voltage. But let's see what happens. I'd like to hear the vertical. That's what I'd really like to hear. And I don't even think our vertical tube is lighting up. There it goes. I cleaned these sockets. And I'm red plating the horizontal output tube. Okay, let's try this again. I don't know what happened. Maybe the horizontal oscillator tube got moved around when this is going to be one long restore video. That will ruin that tube so fast. Okay, there I saw the horizontal oscillator start. I saw the dip. I moved the horizontal oscillator tube when I put the test adapter in. Okay, what the hell? Where the high voltage at? We had a 2-inch arc a minute ago, and now what's going on here? Why is this so far off? What's up with this? We have no vertical. Without it connected to the CRT, we have 20 kilovolts. Wow, we have actually have a really bright raster with lack of horizontal deflection. This is the wire to the damper, and on the 15 it has its own tap on the flyback. On the 16 it connects to pin 3, which goes to the horizontal centering. I'm going to try, let's make dangerous here. I'm going to look at this, let these tubes warm up a little bit. This might not be easily compatible, especially for a resurrection. Tube's still not hot. That tube got damaged by red plating it. Come on. If you had a fully working set, it would be a lot easier to try and adapt a different flyback than trying to resurrect something in this bad a condition and then adapt parts. So here we go. Let's see what happens. Come on, wake up. Can you see that? So I'm going to try going to 3 and see what the difference is. Ooh, this might be better. So, come on. Going to 3, we got 165 milliamps and 12 kilovolts, and this is coming up. And going to here, we have, well, let me see, less high voltage and more milliamps. We definitely have a better tuned circuit going to 3 than going to here. Look at the cathode current there. And the high voltage is 13. I'm going to go to 3. The high voltage is now 16. Okay, now I got a strong horizontal output tube in it. What the hell? Here we go. Oh, baby. Look at that. That's on 3. And look at this. We got weird linearity drive lines in the picture. So getting that off of where the damper's connected on the CTC15 and getting it hooked up just like it is in the CTC16 made all the difference in the world. Look at this high voltage I got now, almost 26 kilovolts. I'm on 180 milliamps and I got the voltage down to about 110. I still don't have full horizontal sweep. It's not filling the screen. Next thing I want to check is the focus. Okay, I'm having trouble turning it, but you can see the focus is working here. So that's focused in as good as it can get. But here's where we're at. Now those lines that are there, I don't know what those are about, and I don't know why we have the lack of deflection. That could very well just be because the G2 is floating. Or is it G1? G1 is floating. They're not even connected. I think these are, yeah, these are probably G1. And they're floating. This is where the color information goes in. So anyway, I got a couple really nasty RF burns. I touched this and oh, they're gonna hurt. I believe I caught another mistake I made, which I had 1 and 2 reversed. And that's why our B boost was kind of low and our sweep was kind of short, our horizontal deflection. It's a lot better now. I think I'm going to set up and try and do a purity on this, because remember we changed the CRT. So let me see if I can set up and do that. It's just about ironing out all the little, you know, details and getting these things wired in right. And these flybacks are very exchangeable between, you know, not between Zenith and RCA, but between CTC15 and 16 and 17. Well, the rectangulars are a bit different. I put all the accessories back on, the magnet and the, yeah, whatever, it's too late, I'm too tired to think of it. The blue lateral magnet, the purity magnets, the clover leaf. Remember I put these yellow dots on everything when I took it apart, changed the CRT. So let's try and do a base purity setup. We don't need anything else except sweep really working to do purity. Looks beautiful, doesn't it? Okay, I'm just going to do base purity. Can't do convergence, so turn green and blue down. I'll turn, okay, turn red up. Real red, isn't it? Really? I need to bring that red dot into the middle. I'm moving the purity magnets. Psychedelic, man. The hell. That's blue, green, and red. I can't even bring the red into the middle. Huh. What the hell am I doing wrong here? Check out the video output tube. I just noticed this. It's glowing like white inside. Like, is it being overdriven or is it gassy? Last night when I couldn't get the basic purity to set up, I started to dig a little bit more into the flyback that I used, which was this, another one of these. And like I stated in the previous video, I had a whole bunch of these. And this is a 50 23506, which is a Sylvania part. And I thought this was out of a Sylvania CTC16 clone roundy. Well, I was wrong. It's out of this set right here. Now, sort of amazing I was able to even get this to work at all, because this circuit is quite different, because with a rectangular set you have pin cushion, and with a roundy you don't need pin cushion. So the way that this thing hooks up is a bit different, not totally different, as it's working. I don't know if this is what's keeping the basic purity from being set up, or the fact that all the blanking and that is not hooked up. But yeah, this flyback goes to this set. I went back and dug through my stash and I found the appropriate roundy CTC15 clone flyback. And I don't know how I messed that up, but it makes for an interesting video. And this one's complete. It still has the shunt regulator and the rectifier, and it's got the 15 has the focus coil attached, the bleeder resistor, the filter, capacitor. I mean, this is all, this is the horizontal, what do they call it, side to side. This is the horizontal centering. This right here is the wire to the focus. So this is all inclusive. This also has the separate tap for the damper right here, which was broken. I had to fix it. But yeah, and this one is testing good. So I tried pulling the tube out and the current draw goes down to about 10 milliamps. It's because the filament is loading this down. So if we can't get the one that's in there to work, or if I can't get the purity to work, then I'm going to change the flyback. I guess the flyback could screw up the signal to the yoke, and then we can't set the purity up. It's very interesting. I would have had no clue that a flyback would make it so you couldn't set purity up. But okay, this right here is a 15 flyback. That other one is for a rectangular set. This should win an award for safety, shouldn't it? Considering almost every one of these wires has a pulse on it over 2,000 to 8,000 volts and up. Okay, so I got 1 and 2 hooked up. Pin 1, I'm starting to just memorize how this goes. Pin 1, and this is the CTC15 flyback. Pin 1 also is the blue wire going to the yoke. I left the 2 wires going to the centering pot under the chassis disconnected. I'm just using their centering, the CTC15 centering pot. I disconnected all of the focus stuff on this flyback. So I disconnected the diode, I disconnected the 2 leads from 1 and 2 that go to the focus adjusting. So what I did is I just borrowed the diode off of the focus rectifier off of this flyback and got it hooked up to I got my phase detector hooked up there. This lead here is the focus lead from all this stuff that I disabled. This is the high voltage cap that connects here, but because it's so far away I used mine I made. I'm using their high voltage rectifier. I got the shunt tube pulled out for right now. What I'm going to do is I'm going to power this up, and I'm going to see where we want to. This wire here comes from the damper back there. I'm going to see if we want to hook it up to here where it goes on the 15, or down here where it goes on the 16. And I'll look at the efficiency, the high voltage to the cathode current efficiency. Now, you got to be real careful with this, because this probably won't shock you and kill you, but it will burn the living shit out of you. So if I go here, my cathode current is 190. My high voltage is 20 kilovolts and climbing. If I go up here, cathode current's a little bit higher, high voltage is a little bit higher. Up here is where they have it connected in the CTC16. Okay, on this Flyback it seems to work a little better with it where it's designed to be hooked up. So I'm going to hook it up there. Wonder for focus voltage should be around 4, and it is. It's right on 4. Okay, that's good. I plugged the shunt tube in back there, the high voltage regulator, and the high voltage regulation is actually working. If I turn this down, it's actually working. So we'll have to take a look at this tonight and see what, I also adjusted the cathode current for minimum. Look at, I'm at 180 milliamps now, really good. What I want to do is I want to adjust this for 15.5 kilocycles and then adjust the cathode current, because without a sync signal you should adjust your linearity coil, your efficiency coil, with your a picture on it, not just the oscillator free running, but you need it actually running at the right speed. See that little hole right there burned in my hand? I brushed up against the damper tube wire, so I put a newer horizontal output tube in it, and I'm looking at the boost voltage 874 cathode current, and I can really crank the high voltage up now. If I go here, you can see I can really crank that up. I'm going to cap it down a little bit low, simply because to cut down on the X radiation with this not shielded. You know, the higher the voltage, the more X-rays you get out of it. So I'm going to cap it down right there. So we're looking good with the CTC16 Flyback. Interesting, I just came out here this evening to turn it on to do the purity with the different Flyback, and it popped here, and then it was arcing from where that little standoff capacitor thing goes through the tuner. Very weird. Wow, I can tell you this looks better already. That should be just red is turned on. So let's see if we can move that red splotch into the middle. No. What? It's the same. It's the same as with the rectangular flyback, except you don't have weird drive lines in the middle of the screen, but I still can't set the purity up. I can't. I need to pull the red blob into the middle. That's like backwards right there. And that is definitely the red gun. That is the blue gun. Huh. I don't know. I'm lost. Why can't I set the purity up on this thing? The degaussing is working. I'm going to try manually degaussing it. While I was doing this, I saw a arc start under the horizontal oscillator tube. Did that affect it any? Oh, it did. Wow. So it wasn't the flyback. It needed to be degaussed, but the internal degaussing is working. That's what we want. Not great. I'm going to adjust the horizontal centering. Okay. That's pulling the yoke back, pushing the yoke forward. Okay. Wow. So I changed the flyback because it needed to be degaussed. That's a real award winning. I can't believe that. So you're telling me that the flyback wasn't the problem, it was just the degaussing. I could use that flyback out of a rectangular set. Really? I'm going to try and tweak the vertical. That's vertical linearity. This is vertical height. What happened there? Okay, so looks like the vertical works. Looks like the vertical works, and it looks like the horizontal works. Let's try some other colors. That should be blue. Okay. That should be green. Look at that. Wow, so it was just the degaussing. I've spent all that time changing that flyback. I mean, we got the right flyback in it now. We got the 15 flyback, but it was just about spending all that time when it just needed to be degaussed. It has internal degaussing. It's working. Maybe it's just not enough. There's what the high voltage RF burn looks like from the damper 3 days later. See how it burned a little hole in my hand? Anyway, I'm gonna check the degaussing, and this wire here goes to the degaussing coil, which is this metal thing wrapped around the CRT with the coils on it. And the way this circuit works is down here there's a VDR and a thermistor, and when you first turn the set on, it hits it until the thermistor warms up. So here we go. This is always hard to see this thing in the... Okay, I'm turning it on. So we had 15 volt peak. Okay, now we're gonna look at the oscilloscope. I'm gonna turn it on. Now I think as the tubes warm up, That's nice. That was awesome. Now I think that might have blown the circuit breaker. I'm going to try resetting it here. Yeah, nice. That's what you call carbon tracking. Oh yeah, let's get this party started. Self-extinguishing. So this is carbon tracking, pure and simple. What is carbon tracking? When something burns and becomes conductive, basically. And on the newer stuff, they usually have holes. And see that hole right there in the circuit board? That might be there to prevent carbon tracking. Anyway, it's a known thing. It happens a lot in automotive. It can happen in stuff like this too. It might partially be because the 400 volts is spiking because so many of the tubes are removed, but it still shouldn't do that. So I'm going to clean it up with some carburetor cleaner and an acid brush. This is an acid brush. And you can kind of see what happened here. This down here is ground. This is ground. And then this point right here where this wire's connected, this is like B+. So it carbon tracked and arced right here and just spread. And we can, to verify this, I can pull the factory manual on the 16 and it'll show the layout of the traces on the board. Okay, it's all fixed. And that's just a ground wire that helps support the horizontal output. And if I remember correctly, that's a common failure on the CTC16, that little trace I replaced to the wire. And it causes blooming if I'm not... It causes low high voltage and blooming if that trace breaks. So anyway, it's just a ground to a couple resistors right there to the horizontal output transistor. So I got it cleaned up. It's not going to arc again, at least not there. Okay, here we go again. I'm going to power it up. Ooh, no fire this time. Although maybe the circuit breaker is still blown. Okay, we got our raster back. Now that we got the high voltage and horizontal and CRT kind of working, I'm taking a look at this. And I know I talked about pressure washing this thing in the beginning, but I really don't want to do that if I can avoid it. I mean, this is just a resurrection. Pretty much once it displays a picture, it's going to go in the trash. I'm just afraid of all these little tiny fine wires everywhere, because if I pressure wash it, I mean, I'm putting pressure to it that'll peel your skin off, and it would destroy these. I mean, I've already got like a broken peaking coil here, so I need to see. Yeah, I kind of want to be gentle with this. Next thing I want to do is I want to populate these 4 tubes. That way we get our blanking signal to the G1. Fix this. I mean, this is just awesome. No wonder why it's carbon tracking and arcing. Maybe a vacuum is a better... Get the vacuum back out on this thing. Okay, I'm trying to fix this broken peaking coil. I was able to chip enough away on this peaking coil to get to the little micro hair wire, and was able to solder it to that lead, that new lead I got wrapped around the bottom here, and then I put some epoxy on it, so I'm waiting for the epoxy to dry, then I'll disconnect it and try it. Here's another one that was loose, so 1.8 ohms, 0.01 what, millihenry? I wish it was in microhenries. It looks like my repair here was successful. I think these are 620 microhenries is what they are. But 0.61 millihenries, I guess. This is that capacitor that had the chewed off rotten lead. I'm actually fixing the capacitor. Why not? There you go. It's a 0.22. I love how anytime you work on this, it smells like, with a soldering iron, it smells like burning hair. That adds a real sensual experience to working on this set. Anyway, I'm thinking of pressure washing just the tube sockets, because I don't know if disc capacitors are waterproof under 1,000 psi of water. But some of these sockets, you know, are so bad that, and I don't know if this stuff is water soluble or not. Here is like opening a gift from the fetish store. Oh, jeez. This is awesome right here. Vacuum. Maybe I should blow it off, but again, you got all these really fragile wires in here from all these coils that are coming apart. I don't even want to do that. Look at this. There's actually like corrosion on these little ceramic tubular capacitors. Yeah, I don't know. I don't know if there's any hope for this thing. Here's another one of those little peaking coils I would hate to blow apart with high pressure water, but yeah, I think I'm going to pressure wash the tube sockets out. I'll spray some really hardcore cleaner on them, let them soak for a minute, and then I'll pressure wash them out, and I'll leave the rest of it alone. I mean, some of this I can hit, but anywhere where there's inductors, I don't want to risk blowing them apart with high pressure water. Yeah, there's an inductor there. They're everywhere. I mean, that's what a TV is it's all coils. Coils and capacitors. So we'll make this part 2. We'll see you in part 3. It's probably be a 4-part video if it gets that far.